Hello students, welcome back to the third video of this playlist. So in this video we will be solving question number 3 from statistics 2 June 2024 paper. So let's see what's the question number 3 is about. Okay, so basically question number 3 it is related to multiple concepts, you can say, from your statistics 2 syllabus. To be more specific, the concepts behind this question number 3 is from sampling distributions that has been discussed in chapter number 6 of your statistics 2 book, and also the next part D, the further parts, the later parts of question number 3. It is basically from hypothesis test, that is finding the critical regions, stuffs like that. So basically you can say it is a combination of chapter number 6 and chapter number 7 from your statistics S2 book. So in order to be able to solve this question number 3, definitely you should have clear idea, and definitely you have learned the concepts from chapter number 6 and chapter number 7 of your statistics 2 book. So let's get started. Okay. Okay, question number 3. So in question number 3, what they asking, Jian owns a large group of what shops. Okay, she decides to visit a random sample of the shops to check if the stock taking system is being used incorrectly. So she decided to visit a random sample of the shops. So she is visiting a random sample of shops and checking whether they are using the stock taking system correctly or incorrectly. That's it. Okay, so for part A, suggest a suitable sampling frame. What? Sampling frame for Jian to use. Sampling frame, what does it mean? Sampling frame, basically sampling frame is the whole set of data. Okay, sampling frame in terms of statistics, it is a whole set of data on which the investigation will be carried out, or the statistical investigation will be carried out. This is the sampling frame. So in this case, Jian is visiting a large group of shops. That means she will be doing the investigation on this what? List of large group of shops. So in that case, sampling frame would be what? The list of shops. The sampling frame would be what? The list of all the shops. Okay, I think so. You have understood. Sampling frame is basically the whole set on which the whole set of data on which the investigation will be carried out. So in that case, what we can write for part A, so sampling frame is what? The list of what? All, or the group of all shops. Okay, this is the sampling frame. Okay, because on this list, from on that group of shops, the investigation will be what? Carried out. Like Jian will be checking whether they are using the stock taking system correctly or incorrectly. That's it. Okay, next, part B, identify the sampling units. Sampling units, what does it mean? Sampling units, look, sampling frame is the whole set of data. Don't need to memorize anything, just try to understand from their words. Sampling frame, the whole frame, the whole set of data. Sampling units, that means a singular unit. Okay, here in part A we got the sampling frame is what? The whole set of data, that is the list of all shops, right? So what are the sampling units here? This sampling frame is the group of what? It's the list of shops. That means each of the what? Each of the data are here what? Shops. So that means sampling units is what? Each of the shops. Okay, sampling units is what? Each of the shops. It would be it would be what? It would be each of the shops. Okay, so that would be what, each of the what, of the shops. This is the sampling units. Hope so you understood well. Next, part C. For part C, give one advantage and one disadvantage of taking a sample rather than a census. Okay, at first you need to understand what is a census and what is a sample. A census is basically a survey that is, or an investigation that is done on the whole population. Okay, like definitely you have like heard about population census that is done in each of the countries over the world, right? Where they calculate the whole population, right? Exact population. So this is basically what, census. Like it considers the whole population. So it considers the whole population. So what is sample? Sample is basically just a part from the whole population, like on which the investigation will be done. And like, since it is very difficult to consider the whole population, right? It's very like you need to arrange many things. It will be very expensive, right? To consider, it will be much hassle to consider the whole population. So in that case, sample is considered as what, a sample will be taken from the whole population, and all the necessary investigations will be done on that picked up sample. Okay, this is the difference between sample and a census. So like, the advantages of using a sample is very easy, very straightforward. What would be the advantage of using a sample? The population, I already said the advantages and the disadvantages already in my definition, like while describing sample and the census. So for example, since we are taking a small group of data, so in that case, like taking the small group of data, it's definitely it is what, cheaper, right? So one advantage what we can say here, it's cheaper. What one of the advantage we can say here, what, it's cheaper. Sample is cheaper. Sample is cheaper. And what we can say, it's cheaper. And then what, it's definitely it's fast, because you can carry out the investigations on a small group of people, right? Or a small group of data, right? So in that case, it is what, fast. You can say any. Sample is cheaper, fast, and what else you can say? It's definitely what, it is of less hassle. It isn't so complex. So you can say easier to process, you can say. Okay, it's easier to process. Any one you can pick from here. I have given 3 options, you can take any of them. Okay, and this is one of the advantage. And so what you can say about the disadvantage? What would be the disadvantage? Sample is cheaper, we can say sample is cheaper, that's fine. Sample is just a group of data from the whole population. So since it is just considering a small group of data from the whole population, so it might not be like representative, it might not be the exact or the accurate representative of the whole population. Or you can say it might not be it might not give the accurate results as for the population, whole populations. And since it's just considering a small part of the whole population, so it might be biased. Why it might be biased? Because since we are considering a small group of data, so small group of data might be biased towards anything else. Okay, it might be biased towards one of the factor. Okay, so we can say this advantage is that sample might not be might not be the exact represent or the accurate representative, accurate or perfect, you can say any word you can say here, not be the accurate representative of the what, might not be the accurate representative of the whole population. Okay, whole it should be what, population. Okay, that's it. Or you can say, since it's a small group of data from the whole population, it might be what, biased. That's it. Okay, there's lot of options you can write here. Just you can write the one which suits you. That's enough. Okay. Okay, part D. Okay, we just finished part C. Part D. Let's see what they have asked in part D. Jian believes that the stock taking system is being used incorrectly in 40% of the what, shops. It's being used incorrectly in what, 40% of the what, shops. To investigate her belief, a random sample of 30 of the shops is taken. Okay, so she is taking how many shops? 30 shops. Okay, so she is taking what, 30, like a sample of 30 shops. Okay, and on that group he will be doing the investigation. Okay, using a 5% level of significance, the level of significance is given there. Find the critical region. We need to find out the critical region for a two-tailed test. Okay, figure out like what the questions has asked for. Two-tailed test of Jian's belief. You should state the probability in each tail which should each be as close as to 2.5%. Okay, fine. So we need to find out the critical region in this case. Okay. Okay. So what we can do, we know that this investigation, this hypothesis test is two-tailed already as per the question. So for two-tailed test, what we know, there will be an upper tail and there will be a lower tail. Okay, and before considering that fact, let's see the distribution. Like he took 30 what, group of shops, 30 shops, right? So in this case we can consider part D. We can consider X is distributed binomially. Why it is binomial? Because this is fixed number of shops, that is 30, right? 30, and probability is what, 0.4. Okay, so what is X? X is representing what, the number of shops that are using the stock taking system, the stock taking system incorrectly. Okay, system incorrectly. Fine, this is the variable X. Okay, now we need the lower tail at first. For the lower tail, what we know, for the lower tail, what would be the case here? We know that for finding the critical region for the lower tail, what should be the case? Probability of X less than or equal n should be less than what, 0.025, right? Because 5% level of significance, so the what level of significance will get halved. So let's move on to binomial what, distribution table. Okay, so from the binomial we need n equals to what, 30. We need n equals to 30. Look, this is n equals to what, 30, and the value for p should be 0.4. The value for p should be 0.4. Here you go. So we need to consider the value of the n such that probability of X less than or equal n is what, less than 0.05. This is nothing but, sorry, not 0.05, 0.025. So this is this one, right? This is less than 0.025, and the next one you see it is just greater than 0.025. So ignore this one. So we got 0.0172. Probability of x less than or equal 6. Probability of x less than or equal 6, we can write what? Probability of x less than or equal 6 can be written as x less than or equal 6. It is equals to what? 0.0172. Okay, which is less than 0.025. So what we can say? So x equals to 6 is the what? Is the critical value. Okay, it's the critical value. Okay, next, the upper tail. For the upper tail, what would be the case? For the upper tail, probability of x greater than or equal k. Earlier one was n, so here it would be what? K should be less than 0.025, as like as before. Okay, so let's see the probability distribution again. For binomial distribution, we need to go for what? N equals to 30 and 0.4. So probability of x greater than or equal k should be such that what? It's less than 0.025. So which one is this? Look, this is the one we are looking for, because 1 minus 0.9788, it would give you what? 1 minus 0.9788, this will give you 0.0212. It will give you 0.0212. Okay, it will give you 0.0212, which is less than 0.025. And if you go up, like if you consider this one, the next one, this one, then it is basically giving you even less than 0.025. Okay, so this is the what? The at least minimum possible value for k. Okay, because if you go above, if you consider 16, it becomes 0.9519, was the difference from 1 is what? 0.0481. Okay, so which is greater than 0.025, so not acceptable. So only acceptable is what? 0.9788. Okay, so what we can write here is that probability of x probability of x greater than or equal, what we got earlier, it was 17, I think, or 16. We need to check it again. It was okay, n equals to 30, isn't it? Okay, it was 0.9788. It was 0.9788, and it was for 17. Yeah, it was for 17. Okay, so it was for 17. So let us consider that. So probability of x greater than or equal what? 17. Okay, 17, it is equals to what? 1 minus, or if you consider x greater than or equal 17, then it would be 1 minus probability of x less than or equal 18. Okay, so that means we should go one above. X less than or equal 16, sorry, 16. So that means we need to go one above. That means we want to have 1 minus 0. What? 1 minus the probability that the probability that we have just seen in, like, that we have selected from the distribution. 1 minus 0.9788, right? Okay, so in that case it is x less than or equal what? 16, right? Not 16, it would be x less than or equal 17. For that probability, this is 0.9788, and that means it should be x greater than or equal what? 18. It should be x greater than or equal 18. Okay, so what you will get? You will get 1 minus 0.9788, so that is 0.0212. It is 0.0 what? 0.0212, which is less than 0.025. Okay, so what we can say, so x equals to 18 is the what, critical value. That means this is the first outcome that lies within the critical region. Okay, so this is why it is called the critical value. Okay, so what we got, the critical regions, we got the critical regions. Okay, what are the critical regions? X less than or equal, what was that, x less than or equal 6, and it should be or, since they are not common, x greater than or equal what, 18. That's like these are the range of possible values for x, such that it will be the critical region. That's fine. Next is part E. What they have asked in part E, the total number of shops in the sample of 30 where the stock taking system is being used incorrectly is 20. That means they got x equals to 20. Using the critical region from part D, state what this suggests about Jan's belief. Give your answer. Give an answer for your give a reason for your answer. Okay, so in that case, what we got, the critical region, x greater than or equal 18. But the outcome they found from the what? The outcome they found from the like test, hypothesis test, it's what? X equals to 20, which lies, so it lies within the critical region, right? In the what? Critical region. So the test is what? Significant, right? So we will reject H0 and we will accept the H1. H1 is what? H1 is basically the Jan's belief. Hence, what we can say? Hence, the test shows sufficient evidence to support what? To support Jan's belief. Okay, Jan's what? Jan's belief. That's it. Part E. Now next is part F. In part F, what they have asked for, Jan introduces a new, simpler stock taking system to all the shops. She takes a random sample of 150 shops. How many shops? 150 shops. That's a large number. Okay, and finds that in 47 of these shops the new stock taking system is being used incorrectly. Okay, in how many? 47. Okay, so they got the outcome of the statistic, that is 47. Okay, so using a suitable approximation, we need to use what? Approximation at the 5% level of significance, whether or not there is evidence that the proportion of shops where the stock taking system is being used incorrectly is now less than 0.4. Okay, the things that I have marked here, these are very important points for the starting of the hypothesis test. Okay, so we need to use approximations here. At first, consider the what? The variables. Okay, what are the variables here for part F? Oh, it's not highlighter, we need pen. Okay, so for part F, at first you will consider, what we will consider? Okay, at first we need to consider the what? Random variables. Okay, we need to consider the random variables. So how can we consider that, the random variables? We have already considered x, so let's consider y. Y, it's distributed how? Binomially with 150, and the probability is how much? 0.4, isn't it? 0.4. It can be approximated using z distributed what would be the suitable approximation here? Did they mention here? Did they mention? No, they just said using a suitable approximation. So you need to consider the approximation. So in this case, 150 times 0.4, what would be the value for 150 times 0.4? It gives you 60, which is pretty large. That means here you can't use Poisson approximation, you have to use what? Normal. Okay, it's 60, and since you can see that the p is what here? This is the p, right? P, it's closer to what? 0.5. Since it's closer to 0.5, so definitely here what is suitable? Normal approximation. Okay, so the mean of normal approximation is what? NP. This is n and that is p, so NP, and the variance is NP times 1 minus p. Okay, so what is y there? This is what? The number of shops that are using the stock taking system, what? Incorrectly. Okay, this is the variable y. Now write the null hypothesis. The null hypothesis is basically the one which is assumed to be correct. What we will assume to be correct? That p is equals to what? 0.4. This one we will assume to be correct. And which one is the claim? The claim is that p less than, I have marked in the question, remember, less than 0.4. This would be the claim. This would be the goal of the hypothesis test. Okay, so what's the level of significance like mentioned there? So the level of significance here, it is 5%. Okay, it is how much? It's 5%. So at what level of significance? At what? 5% level of significance. What we can write? At 5% level of significance, they got what? X equals to, they got y equals to what? 47. Okay, they got y equals to 47. I marked it in the question. They got y equals to what? 47. So we need, since it is one tail, so we need to find out whether y equals to 47, it lies within the critical region or outside the critical region. Okay, so y less than or equal to 47. We are finding less than, since the null hypothesis is what? Just less than. Okay, okay, so it can be approximated using probability of z less than or equal. Look, this is y is distributed what? Y is distributed binomially, which is discrete random distribution. But z is what? Distributed normally, which is continuous distribution. That means we need continuity correction here. So y is less than or equal 47. That means 47 is included within this probability. So in that case, it would be, the continuity correction would be 47.5. Okay, so probability of z less than or equal 47.5 minus what? The mean is 60 over square root of 36, right? Square root of 36 is 6 basically, so we kept it as it is. Now you can use your calculator to find this value for the probability. 47.5 minus 60 over 6, this is negative 25 over 12. Go to your statistics mode, shift at first, like if you are using Casio 991EX class V's, okay, then just go to mode just click mode and then click save in, that is statistics mode, and then go for normal CD, that is normal cumulative distribution. So you will see lower, upper. So for lower, since it is less than or equal, that means in the lower end it will be keep going to the negative infinity, so negative 999999. And for the top one, you will put the value, that is what, 47.5 minus 60 over 6. So this is, it gives you 0.0186. So this would give you 0.0186. okay, it keeps going, which is less than 0.05. okay, which is less than 0.05. that means, so what we can understand, so x equals to what, x equals to 47 lies in the critical region, right, critical region, hence what, reject what, H0. Therefore what we can say, the test shows what, the test shows sufficient evidence to support that, what, to support that, the proportion of shops using the stock taking system, what, stock taking system incorrectly is now what, less than 0.4, is now what, less than 0.4. that's it. That's all about question number 3 from S2 June 2024 paper.